Lesson 3.4, solving quadratic equations by factoring. It's best standards MA 912, AR 1.8, and AR 3.2. So solving quadratic equations by factoring. Normally we use the factored form where 0 is equal to a times x minus p times x minus q. Knowing that, we need to know about the factoring trinomial pieces. Once factored, each piece represents a portion of our solution. So m plus b p equals b value. If we are looking at x squared plus bx plus c, and m times p is equal to the c value. So as we go through the problems, you'll understand what I mean with this. So normally to solve for a quadratic equation for factoring, first thing you need to do is make one side equal to 0 and factor the trinomial. So in example 1, they gave us 12x squared minus 2x equaling x. And they want us to solve it by factoring. So first thing we're going to do is we're going to subtract x from each side. So then when we subtracted x over, we became a 12x squared minus 3x. Then we're going to factor out our GCF. So 12 and 3, they're both divisible by the number 3. So that's why we took out 3 out of both of them. And they both have an x in common. So 3 goes into 12 4 times with an x. 3 goes into 3 one time, x and x one time. So we're at this point. Notice that 3x is what we took out for GCF. And now we're to distribute property, I would get back the 12x squared minus 3x. Once you're at this point, you're going to use a zero product property, which means you're setting each piece equal to 0. So we did 3x equal to 0 or 4x minus 1 equal to 0. We are dividing the first one by 3, and 0 divided by 3 still leaves us with 0. We need to add 1 over first, so we become 4x equals 1, and then divide by 4, so x is 1/4. In example 2, it says solve x squared minus 6x minus 9 equal to 18 by factoring. Again, we're going to subtract 18 from each side, so subtracting 18 from each side, I get x squared minus 6x minus 27 equal to 0. We're going to factor the trinomial. So it means that we need to find numbers that multiply to be negative 27 and add to be negative 6. So in your factor tables, 9 times 3 is 27. And if the 9 is negative and you add a positive 3, you get negative 6. So we're going to put a positive 3 in the first one and a negative 9 in the second one. So when we set each piece equal to 0, which means now I can subtract 3 over. So x is negative 3, add 9, so x is 9. So those are our two solutions. In example 3, they want us to solve an equation by factoring. So it's an acceleration problem. It says the equation d equals vt plus 1/2 at squared represents the displacement of d of a car traveling at an initial velocity v, where the acceleration a is constant over a given time t. It says find how long it takes the car to accelerate from 30 miles per hour to 45 miles per hour if the car moves 605 feet and accelerated slowly at a rate of 2 feet per second squared. So we need to determine some things. It says the first thing is, what is the task? Describe the task in your own words and list any questions that you may have. How can you find your answers? Well, first thing, we need to solve the equation to find time. For the car to accelerate. So remember, A is in feet per second squared. Velocity is in miles per hour. So the question you need to ask is, how do you fix this? Remember, different units. Instead, part 2, it says, describe the method you will use to complete the task. What have you learned that you can use to help you complete the task? So what we've learned is you need to convert velocity to feet per second. And then we're going to substitute. The distance they gave us, the velocity given, and the acceleration. And then solve for time. Okay, in part 3, it says to solve for the velocity in feet per second. So first thing we need to do is we need to do some unit conversions. So again, they started out with, we had 30 miles per hour. That was our velocity. But we need to make that go into feet per second. So 30 miles in 1 hour needs to be changed to, we know that in 1 mile, there are 5,280 feet. In 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. This is going back to your biology days. When we multiply straight across and then divide by the denominator, we end up with 44 feet per second because our hours canceled out, our miles canceled out, our minutes canceled out, leaving you with the unit of feet and seconds. So our velocity on number 3 is 44 feet per second. Then the question says, how long does it take the car to accelerate from 30 miles per hour to 45 miles per hour? So we have to go back to our original equation, and they told us distance was 605. So I'm going to write 605 equals, our velocity is now 44 with a t. And then 1/2 times our acceleration. They told us our acceleration is 2 feet per second. I'm not using the units, squared with our t squared. We're just using our numbers. When we get to this point, I need to subtract the 605 over. So I see 0 equals 1/2 of 2 is just plain 1. So we're at t squared. T squared plus 44t minus 605. So we need to figure out numbers that multiply to 605 negative and adds up 44. So obviously we're going to have a t in each piece. 605 is the same thing as saying 55 times 11. But because it's negative 55 and we need to be positive 44, we're going to be negative 1. So I'm going to say positive 55, negative 11. We set each piece equal to 0. So I see t plus 55 equal to 0, t minus 11 equal to 0. The first one tells us time is equal to negative 55 seconds. The second one tells us time is equal to 11 seconds. Now, we're going with the 11 seconds for a reason. An argument can be used to defend our solution is that time cannot be negative. Okay, in example 4, it says solve 3x squared plus 5x plus 15 equals 17 by factoring. So in their explanation, they used basically a trial and error method. I'm going to show you another way. So when we start with our original problem of 3x squared plus 5x plus 15 equal to 17, yes, you do start out by subtracting your 17 over. So we become 3x squared plus 5x plus, actually a minus 2. Equaling 0. Now at this point, there's a thing called Colombian method of factoring. And what it states is you're going to draw 2 parentheses underneath your equation. You're going to take the first number times the last number. That is negative 6. That is the crossbar at the top, and you need to add a 5 in the middle. So you are plugging in the first value into each parentheses in the first slot. Now I need to multiply to -6 and add to 5. So the only values are 6 and 1. When 5, to get a positive 5 in the middle, the 1 has to be negative. So I'm going to write +6 and a -1. When you're at this point, you just need to reduce where it's possible. Both of these can be divided by 3. This one does not divide by anything. So this one's going to slide. So we get 3x minus 1 equal to 0. The first bubble becomes x plus 2, which is the same thing they did here in their trial and error method. This is just a different way. So I know that x is equal to -2 and x equals 1 over 3 because this is the numerator, this is the denominator. Okay, and the next section is talking about solving quadratic equations by factoring special products. We saw a little bit of this in the previous lesson. A squared minus b squared. This is our difference of squares pattern, which will always follow the pattern of a plus b, a minus b. The other one is called the perfect square trinomials, which is a squared plus 2ab plus b squared. And it means that it can collapse itself onto a plus b squared when it's the same bubbles repeated twice. Now remember that we cannot take the square root of negative numbers. So because those are considered complex, so it means we are going to use the letter I involved. So in example 5, it says solve 81 equal to x squared by factoring. So what they did is they subtracted x squared to the left and rewrote it as in the form of a squared minus b squared. So each piece is being given a power in the form of a power. So there's my 9 and there's my x. So remember, it goes b, and then this instance is b plus a and b minus a. So I'm going to write a 9 and a 9, split my x's. They're different in sign. So I see 9 plus x equals 0, so x is -9. 9 minus x equals 0, so x is positive 9. When we look at example 6, it says 16y squared minus 12y plus 23 equaling 26y minus 13. So first thing we're going to do, we are subtracting 26y from each side. I subtracted 26y to the left, and I become 48. So I see 16y squared minus 48y plus 23 equals 13. Then I'm going to add 13 to each side. So now I see 16y squared minus 48y plus 36 equaling 0. Here's where we're going to deviate a little bit from what they want us to do. So when we go to here, we have 16y squared minus 48y plus 36 equal to 0. First thing I notice is that the number 16, the number 48, and the number 36 are all factors of the number 4. So I'm dividing everything by 4. So I become 4y squared minus 12y plus 9 equaling 0. It's going to make your numbers a little bit smaller. When we're here, now I notice that I can take the square root of the 4 and the square root of the 9. Square root of 4 is a 2, square root of 9 is a 3. If I multiply them, I get 6, and if I double, I get 12, which is the middle number. So I'm going to break it down into 2 bubbles, and I'm going to write 2y, 2y, a 3, and a 3. And since the sign in the middle is a minus, it's 2 minuses. It's the same bubble repeated twice. You only need to solve it once. So I'm just saying 2y minus 3 equals to 0. 2y equals 3. Y equals 3 halves. Okay, in example 7 says solve x squared minus x squared equal to 144. I'm solving a little bit different than the way they want you to solve it. So we're going to say x squared equals the negative 144. And so we know that it's already saying x squared. We don't need to do anything extra. We're just going to go ahead and take the square root of both sides. When you take the square root of both sides, we know that x is going to equal a positive and negative situation. You're going to isolate the negative out, so negative 1, and then the 144 because we're not allowed to take the square root of negative numbers. From the previous lesson, we know that negative 1 in the radical is the same thing as saying the letter I. And then the square root of 144 is 12. So our solutions are x equals 12i and negative 12i, because it's our plus minus situation.